The experiment environment is shown in this video. This box showing is 00, and this is our x-axis, and the blue point line is our y-axis. So this is our overall environment. The x-axis is 2.6 meter and the y is 3 meter, so our whole environment will be 2.6 meter into 3 meter, and we will conduct our all the experiments in this environment. This is our experiment 1, in which we placed a static mode at the location of 90,95. This is unknown node. We have connected this mode to our PC or whatever that can receive the serial command. Now to run or to calculate the location, what we have to do, we have to go to our program and do Java run. With this you can see a mode connected to here. You have to select it, you have to set the actual location. Just for comparison, as we know, we have made 90 and 95. Okay, number of location request 5. Let's say the window is our 5, and IPI we have 8 anchor nodes. We set this experiment. Just we will press start and our experiment will be started. All these calculation will be done here. See, now that this mode will send the commands to these anchor nodes. It's not the command, it will send the RSSI signals. So if you see here, after some time, see now this is the yellow light says that it is receiving and then forwarding its received signal to that unknown node. This unknown node blue light, now if you see the blue light, this means it is sending the message. If you see here, we are getting the location 118 and 60. That means we are getting the x coordinate as 118, another one is 60. That is not bad compared to the coordinate 95. So it is the 30 centimeter difference what we are getting. Okay, so this is our overall experiment. The experiment, the location depends upon the position of the unknown node. If we just change the position of unknown node, our values will dramatically change, and to do that, let me run an experiment again. See, yes, I don't know if it works or no. And in the same way, we can place these nodes onto different locations here to find out different position and comparing on our location meter. Now we will do the next experiment. That will be finding the location on a mobile node. For that, we will connect this mode onto our robot, and then we will try to find out the locations. The changes in a program you need to do, you have to change the port. To find out the port, which port you have to go to the robot computer properties hardware, then comes device manager, and you go to the ports. This is for vector nav, and this is for our telescope mode. So you just write this port onto the this and you recompile it from here, rebuild, and then you again copy the solution and try to run the program. This is our Wi-Fi board lab. It establishes a Wi-Fi connection with any other PC. To establish a Wi-Fi connection, if you see far there, let me focus. This is our Wi-Fi access point, and this robot and our PC tries to connect to the same access point. This Wi-Fi board lab has an IP camera. This is an IP written over it. It is an IP based machine. This is the IP that is showing on. It is a moving robot or a car style robot, so it has wheels that can help it to move. It is got a complete PC or a complete machine that can perform computation. It is a small computer, we can say, that has an Atom processor on it. Now, to help our robot in finding the orientation, we have installed an extra hardware that is called as vector nav, that is developed by Vector Nav organization. This VN100 has different sensors, but we uses yaw to find the orientation of a robot. This is a vector nav. We have connected this to the USB port, so this red light shows that it is connected. The next thing that we have connected to our robot is this telescope mode, that is also called unknown node, that will be used for finding the location of the robot. So for the localization purpose, now we will be using our Wi-Fi board to interact with these modes and a Wi-Fi connection to find out the location, and with the Wi-Fi connection it will tell us here that what is the location. Now to connect to the robot, come to the PC. What we will do, we will open remote desktop connection as seen over here. Okay, once this remote desktop connection, you will be asked with the username and a password. The username is root and the password is Wi-Fi board. You come here, you go to the services. Here it has a default server that is running, so we have to stop that server that is called as Wi-Fi port server. If you can see, just stop this service. Now you can copy your own program. I'm going to close it. Okay, just minimize it, go here and open the FTP connection at the IP of the robot, and once you open the connection, it will be here. Now you can copy your program that you have made here. After compilation, right click, rebuild solution. Once it has been built in success, let me show you. Once it has been built in C, one success, you can go directly to the folder, then release, go to the release folder, and here you have this application file serve track. Copy this, do Control C, and or a right click, copy, and then go here to data and just right click over here and paste it. So what it will be done, it will copy your data. It may ask, so you may replace it. So what it will do, it will copy. After that, you go to the desktop, your robot, you go to C, you go to data folder and run this server. Now this server has everything. It is written by RTRACK team, and it can interact with your PC and other thing, but P we do for robot status. If you see, you can see the status of the robot, okay, and so on. We can do other things. Okay, there are multiple things we have done. See, this is the status of a robot that shows different things, that the battery level and the IR value. Why it is going on, it is because I pressed the enter, and the yaw value, the report location is going on, that what is the location of the robot, and these are the all things are done. Now we will conduct our experiment for finding the position of a robot. This is our intruder pursuer scenario. We have no intruder, we have one robot, so we will consider this as a pursuer. Our intruder will be this emulator that will be connected to this and will be shown, its location will be shown here. So this is our intruder. Okay, now what we will do, this emulator will emulate different positions of the intruder, and our pursuer will follow those positions, and we will try to show what is going on. Okay, now for this, what we have to do, we have to first of all connect to the robot. Okay, so we have to connect to the robot. Our intruder is here, so we have to connect and then press follow here to work. Okay, so what we will do, we will press connect and then follow to catch this intruder at what it is 100. So we have to now press 1. Initially our pursuer is here, we have to go from this location to this location. Our robot will do, it will do turn, and then it will move to the 1 position as shown over here. So robot will have to move.